This experiment is on resonance. We will oscillate a pendulum, and you know how to make a pendulum? You can take any string and any object and tie it. This is a laser torch, and I have tied it to a string. Just hold it at the other end, pull it one side and release. This becomes a pendulum, and you can see this is the amplitude. It goes to one side to some distance and comes back, that is amplitude. And time period, you leave it, it goes and comes back, that is one time period or one oscillations. Now this is called natural oscillation and natural period. And you know frequency is how many times, how many oscillations it makes in 1 second, that is frequency. So this is natural oscillation. I have just left it and it is oscillating by itself. That is why it is called natural oscillation. And time period in such case is natural time period. Frequency in such case is natural frequency. You can also force it. I am holding it at the upper end and I can force it from there. I can shift my hand left and right, or I can rotate, I can apply force there. And whatever frequency I apply by my hand, with that it can vibrate, then it is forced oscillation. So this is forcing, the thing I am doing is forcing. And if I don't do anything and leave it, it is. Now I will force it as well as I will allow it to oscillate by itself. That is when the question of resonance comes. If I am forcing it externally with the same frequency as that of its own natural frequency, then we say that resonance is taking place and amplitude becomes very large. And if the forcing frequency is very different from the natural frequency, the amplitude becomes low. So this phenomena of obtaining large amplitude on natural frequency being equal to the external frequency is called resonance. So see what I am doing. I have taken this pen, my writing pen. I have tied this string to this pen, given 3-4 so that it's securely fixed there. And now look at my fingers. See, this is the natural oscillation. I have just oscillated it. And now what I am doing with my fingers, this is forcing, external force. By rotating this pen clockwise and anti-clockwise, I am applying a force on the upper end of the string, and that is trying to oscillate this laser torch. So by forcing it from the pen, I am trying to oscillate. If I do it, that will be forced oscillation. Now I am doing it very fast. Okay, first very slow. Slowly, look at my hands. It's going very slow, and look at the amplitude. Is it a large amplitude? Is it a small amplitude? Now see, look at my finger and the amplitudes. Look at the speed at which I am rotating my fingers. The frequency of my finger, very low, much smaller than the natural frequency of the pendulum. Okay, very slowly I am turning my fingers, and you see what is the amplitude of oscillations? Almost nothing. It's almost stays there. The amplitude is very small. Now I am doing it very fast. The frequency, forcing frequency is very high. What is happening to the amplitude? Is it large? No, it is not large, it is not slow, it is almost not oscillating at all. Because the forcing frequency was very different from the natural frequency. Now let me try to rotate my hand at the same frequency as the natural frequency of this pendulum. So yes, I am trying to do that, and see what's happening to this torch. Can you see it oscillating? And can you see what is happening? The amplitude is increasing. I am rotating my fingers at the right frequency, same frequency as the natural frequency of this laser torch you had seen earlier. And now you see the amplitudes very high. This is resonance. The natural frequency and forcing frequencies are equal. And see the amplitudes, very high amplitudes. Even now if I increase the frequency, forcing frequency, the amplitude will decrease. See, I am increasing. I have increased the frequency of my hands and see the amplitude. It was oscillating with large amplitude and now it has reduced. So that is how the resonance takes place.